Okay guys, 7.3 right triangles in the coordinate plane. The first thing we're going to do is show you why the Pythagorean theorem is the way it is, like where it actually comes from. So you know that you can use the distance formula or the Pythagorean theorem in order to find the distance between 2 points in the coordinate plane. And I'm going to show you why you can also use the Pythagorean theorem. So really, the Pythagorean theorem is just the distance formula. So if we have 2 points here, A and B, let me show you here. This down here would be the distance of x2 minus x1. That's here. This here is the distance of y2 minus y1. That's this distance here. So we know our Pythagorean theorem is a squared plus b squared equals c squared. Then we can actually plug in for a, x squared minus x1 plus y squared minus y1 squared, sorry, both are squared, equals ab squared. So the length of ab squared. X squared minus x1, y squared minus y1. And so this would be a, this would be b. In other words, a, b. So we see a squared instead, the distance of a. B squared, distance of b. So now, in order to just get it by itself, we need to square on both sides. And so that's what this step looks like. This is your distance formula. So that's how the Pythagorean theorem can be used to help you find distance. Now, how can we use this in the coordinate plane? So if we have a line segment AB, AB has endpoints at -2, -4, and it has endpoints at 6, 2. So we're trying to find the length of AB. I'm going to get a different color really quick. The first thing, as you guys know, is to turn this into a right triangle, because we can use the Pythagorean theorem to find the lengths of right triangles. So why don't we do that here? If you're to count, B to here is 6, A to here is, sorry, not 5, what am I doing? 8. And as a result, you can say that AB squared equals 6 squared plus 8 squared. 6 squared, or 8 squared, 6 squared, that's going to give us the length of AB squared, this guy here. Ultimately, 6 squared is 36 and 8 squared is, what is with my number, 64. And so AB squared equals 100. If you square both sides, the square root of 100 is going to give you AB, and that equals 10. So that means our side is 10. This is just review. You guys have certainly done this already. Now, moving on to the try it out. We're going to prove that triangle RST is a right triangle using the converse of the Pythagorean theorem. We have this triangle RST. R is 6, -1. So right now, just take a moment, make sure you're plotting your points. That's R. S is 1, -4. And T is -5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Great. So we're going to connect those points. Cool. So we're wondering if triangle RST here is a right triangle. So the first thing that we're going to do is we're going to see if our different sides are going to make us have here a right triangle using the converse. So let's look at SR and find the distance there. SR equals, and we're going to use the distance formula, the square root of, this is the converse to the Pythagorean theorem, right? This is the distance formula. So the square root of -4 minus, so this is, we're taking this from here, these 2 points, R and S. R and S. So -4, x2, x1, y2, y1. -4 minus -1 squared plus 1 minus 6 squared. Okay. And when we do all the work, we find out that SR equals the square root of 34. That's the length here. Then, let's go to ST. We'll find the length of ST. or sorry, ST. So we're using S and T. So we're using 6 minus the square root of 6 minus -4 squared plus -5 minus 1 squared. And when you do all the work, you're going to find out that ST equals the square root of 136. And finally, TR. We're putting in all the work now so that we can check it using the Pythagorean theorem. If it works out with the Pythagorean theorem, that's great. We have a right triangle. If we don't, we don't. Okay, so RT or TR, just going to write it in here. You can just write it as I go. And we find out that TR or RT equals the square root of 170. Great, so now we're gonna plug them into the Pythagorean theorem. We've got SR squared plus ST squared equals RT squared. This is just A squared plus B squared equals C squared, but with the actual things written in. And we are going to do the work. So let's say 34, square root of 34 squared plus the square root of 136 squared equals the square root of 170 squared. And we're seeing, is that true? So we have 34 plus 136 equals 170. And the answer is yes, because 170 equals 170. And so we have to write triangle RST is a right triangle because SR squared plus ST squared equals RT, equals RT squared. Sorry guys, I'll leave this up for a second, or you can pause. So this is our answer. Triangle RST is a right triangle because SR squared plus ST squared equals RT squared. So we could show it in a different way. Right triangles. If we remember that a right triangle is made up of a right angle is made up of perpendicular lines, and perpendicular lines have opposite reciprocal slopes. We can prove it in that way. So you look and kind of see if we have two lines, it's looking like the right triangle could be angle S. So if I see that, let's count boxes. And we're essentially going to make sure that we have opposite reciprocal slopes here. So counting the slope of TS, I'm just set it up like this, TS, SR, and RT. Set it up like that, and we're gonna find the slopes. Cool? TS. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, negative 10, 1, 2, 3, 4, 5, 6, 10 over 6. So negative 10 over 6, in other words, negative 5 over 3. That's the slope. SR, 1, 2, 3, 4, 5, 1, 2, 3. So positive 3 over 5. So far, these check out. These are opposite reciprocal slopes. And then RT, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7. So that's negative 7 over an 11. So because the slope of TS is negative 5 over 3, and the slope of SR is 3 over 5, and those are opposite reciprocal slopes. Triangle RST is a right triangle. So you could do it either way. You could do it with the slopes, or you could do it this new way with the distance formula or the Pythagorean theorem converse, and then checking it with the Pythagorean theorem. Both are great methods. And either way, you have just proven with the Pythagorean theorem that you have a right triangle.